Welcome back, guys. Now time has come when you will be learning the theories and concept regarding the shape of different molecules. Let's start with the first theory, VSEPR theory, valence shell electron pair repulsion theory. Be ready for that. Now we'll be studying VSEPR theory, valence shell electron pair repulsion theory. It was given by Sidgwick and Powell. Sidgwick and Powell in 1940. It was to understand the shape of molecules according to lone pair or bond pair repulsions. It was repulsion theory, lone pair or bond pair repulsions. So, what were the repulsions about? The repulsions were about lone pair repulsions, which is designated as LP, lone pair bond pair repulsions, which is designated as LP, BP, bond pair repulsions, that is designated as bond BP. So we know that like charges, they repel each other, and unlike charges, they attract each other. So here I am talking about the repulsion for electronic repulsion. Electronic repulsion, which will distort the shape of a regular geometry molecule. So these repulsion effects, these results in deviation from idealized shape or bond angles. That means regular shape, which includes what? Linear, trigonal, pyramidal, tetrahedral, like that. Now, when we predict some geometrical shape, okay, there we assume two things. The one is lone pair thing and the another is bond pair thing. So you can see here the shapes when there is no lone pair on these molecules. There is no LP, I will write. There is no lone pair electrons here. It is linear, it is trigonal, planar, it is tetrahedral, it is trigonal bipyramidal. In the previous slide, trigonal bipyramidal it should be, or trigonal planar, okay, trigonal planar. These all are regular shape. These all are regular shape without any lone pair. Now what happens when lone pair comes and distort the shape? That we will see with a video. Be ready. Chemistry VSEPR theory. When we talk for VSEPR theory, let's see this molecule. This molecule is linear, two bonded pairs and zero lone pairs electron, zero lone pair electrons. It is linear in shape. Our next molecule is trigonal planar. It is having three bond pairs and zero lone pairs. Next is bent shape. Have you ever wondered for water? It's a bent shape. Two bond pair and one lone pair. Again, if there are two bond pair and two lone pair, that is also called as bent. Now see this molecule, trigonal pyramidal, when there is one lone pair and three bond pair structure. These all are the 3D animated videos. Shape. This is T shape, ClF3, 3 bond pairs and 2 lone pairs. Tetrahedral like CH4, 4 bond pairs and 0 lone pair. You can see this in spatial arrangement. Seesaw structure, 4 bond pairs and 1 lone pair, like SF4. Square planar, 4 bond pairs and 2 lone pairs. Square planar, XZF4. Trigonal bipyramidal, 5 bond pairs and 0 lone pairs, PCL5. Square pyramid, 5 bonded pairs and 1 lone pair. Square pyramid. Octahedral, 6 bond pairs and 0 lone pairs, octahedral, SF6. So these were some regular geometry which we have discussed. Now we saw that linear in shape, those are of BAB type, like BeCl2, HgCl2, or of AB type also. Trigonal planar, these all are regular geometry shape, like BF3, AlCl3. What is the theta angle? Theta angle is 120 degrees. Next is tetrahedral, that is CH4, NH4 plus, bond angle is 109 degree, 28 minutes. Next is trigonal bipyramidal, PCL5, PF5, like that. And this is your octahedral, SF6, octahedral. A octahedron you can assume in space. Let's come to now irregular geometries. Irregular geometries, you can see here 2 BP and 1 LP, that makes it bent like SO2. Bent shape is in water also. How is it? It is AB2 and E2 type, that means 2 BP and 2 LP also. Trigonal pyramidal we call 3 bond pairs and 1 lone pair, like NH3. The geometry is trigonal bipyramidal, but the shape is tetrahedral. Okay. The regular geometry should be tetrahedral only, but it went to this shape. Okay. Geometry is tetrahedral and shape is trigonal pyramidal. Let's come to SF4. 4 bond pairs and 1 lone pair. Trigonal bipyramidal it should be, but due to lone pair there is some distortion and it got to seesaw structure. ClF3, it will be T-shaped, like a T-shaped. There are 2 lone pairs and 3 bond pairs. BRF5, square pyramidal, there is 1 lone pair, that's why it's not octahedral. There is distortion in the geometry. So these all distortions happens due to electronic repulsion if there is some lone pair. So the point which is to remember is that we have to minimize the electronic repulsion. So the lone pairs must be at axial positions. When the lone pairs are at axial positions, they suffers less repulsion. This should be kept in mind. And always the least repulsion will attribute to more stability. More stability. And the lone pairs, of course, they distort the regular geometry, which are the symmetrical too. We have studied in this part about the repulsion theory, right? Repulsion between the electrons, lone pair, bond pair, and repulsions, which makes the shape distorted sometimes.